Welcome everyone to today's traditional FMEA overview webinar. Today's webinar will be approximately 45 minutes or so, followed by a question and answer session. If you have any questions during the webinar today, please use the chat or the Q&A features, and I will ask Jim all of your questions at the end of the presentation. So now I'd like to introduce you to the speaker for today. James F. Leonard is a consultant and educator who specializes in teaching the principles of the late Dr. W. Edwards Deming as a new system of management. Jim has worked with manufacturing and service organizations throughout North America, Europe, and in China. He serves as a senior consultant for Quality Support Group in Westford, Mass. For 29 years, Jim presented his seminars for the Division of Corporate and Professional Education at the Worcester Polytechnic Institute in Worcester, Mass., where he also served as an adjunct instructor in graduate operations and industrial engineering. He works with clients in China as an instructor for the China Institute for Innovation in Shanghai. Jim is an alumnus of the U.S. Naval Academy, where he majored in mechanical engineering and analytical management, as well as the George Washington University and Clark University. He resides in Ave Maria, Florida, with his wife, Kate. They are the proud parents of 6 children and the grandparents of 10 grandchildren. So Jim, we're happy to have you for the webinar today. I think before I turn it over to you for the presentation, I think we have a short slide for some upcoming courses. Great. So this is some of the upcoming QSG workshops. We do have a FMEA workshop on November 17th and 18th. And then also our 2022 internal auditing workshops for AS 9100, ISO 1345, and ISO 9001. If you have any questions about any of these workshops or other quality support group workshops and what we can offer, please let me know. My email is below, and you should all have received an email from me as well. All right, thanks, Jim. So I'm going to turn it over to you for today's presentation.
All right, thank you, Chris. And good afternoon, everyone, except for those who might be out west, and I'll say good morning. As Chris said, this is the traditional FMEA overview. We have, as you saw in the description of this webinar, we have 2 workshops. One, the traditional, that's been around in various forms since the Department of War came up with it in the 1940s. And then the Automotive Industry Action Group, we call it VDA, Verband der Automobile Industry. The EU counterpart of the American Institute Industrial Auto Group, they came up with, published in 2019, a very auto-centric approach to FMEA, upgraded as far as the approach. Many of our clients, however, are sticking with the traditional approach, and that's what our focus is going to be today. So for the most part, even though people talk about machinery FMEA and application or user FMEA, for the most part, when people talk about failure mode and effects analysis, they're talking about one of 2 species. First is design FMEA, a disciplined, a structured review and analysis of a new or revised product design. Why do we incur this pain? To anticipate, to define, to identify, and to take action now during design, when it's cheaper to make changes. Certainly before getting into hard tooling, for example, eliminate known or potential failures before the design is released to production. Again, and that's the end point of design FMEA. Before the design is released to production, we have to stay out of process. I was working with a QSG client. They had done several design FMEAs, and they wanted us to come in and help to expand the effort and accelerate the effort. So I looked at the documents with the corporate quality person. Every one of them was labeled a design FMEA. Not one of them was a design FMEA. How can you tell? You can look at a couple of things, but in this case, look at the potential causes of failure column on the worksheet. Here's one of them that they had. Moisture gets into the unit and causes a short, an electrical short. I haven't released the design yet. How can moisture get into the unit? Selected and specified weak epoxy that might lead to a seal failure and let moisture get in later. That's design. Flatness specification for mating surfaces too loose. It would leave a gap and allow the moisture to get in later on. That's design. And quite often, the difference between a process-related cause of failure and a design-related cause of failure is the four-letter word spec. Bad incoming material, process. Material tensile strength, spec too low. That's design. And it's a major battle to keep people in design during a design FMEA project, because the temptation to morph into process for many is really overwhelming. And that's going to be dependent on you to keep people focused. Second species of FMEA, when people talk about it, process FMEA. After completing the design FMEA project, we want seamless transition. See, in the design FMEA project, is my spec good and proven? If operations or the vendor remain within the specification, we will avoid that failure, and I have proven it with good test and design controls prior to design release. Now, we want that seamless transition into process FMEA to assure that my process is good and capable of producing good product to that good design, a disciplined review and analysis of a new or revised process. Why do we do it? To identify, to define, and to take action now, to improve the process, to eliminate known or potential failures before they reach a customer. Now, in process FMEA, we use the term customer holistically. It includes next operation, it includes subsequent operations, and it includes end user. For the most part in design FMEA, when we say customer, we're talking big customer with a capital C. The one who purchases our product, the one who pays our bills. Though in medical device, it would not only be the surgeon using that instrument, but also we would be considering effects on the patient. In terms of as the design or the process FMEA project begins, the first thing the team has to do is to establish and agree on their scope. What is our scope? In design FMEA, our scope could be at a systems level, a subsystems level, an assembly level, a sub-assembly level, a part or component level. In process FMEA, we could decide to take on the whole process initially, or this stage, or this step. And in making that decision about scope, teams can be guided by this table. And again, these slides can be available to you upon a request from Chris if you would like. But notice here, if I'm working in design FMEA, maybe I'm going to start at a part or component level because that's the only change I'm making. But subsequent iterations of design FMEA, I'll work my way up to the systems level to make sure everything's still working well together. So when I'm moving upstream in that fashion, the effect of failure at one level will be the failure mode at the next higher level. So out in the steel mill on the lower right-hand corner of this table, the failure mode is bad chemistry formulation. Now, maybe it was mixed wrong, or maybe it was a bad formula by design. So what is the effect? Well, the steel's too soft. Now they send that shipment into us for initial processing. What is the failure mode? The steel's too soft. That's the failure mode. What's the effect? We end up with a bent shaft. Now we move on to a sub-assembly step. What's the failure mode? The bent shaft is the failure mode. What is the effect? The piston freezes. Final assembly. What's the failure mode? The piston freezes. What is the effect? The motor burns, and then the consumer's in deep doo-doo out there driving on the highway. On the other hand, let's say in process FMEA, I decide, no, I want to start with the whole process, and subsequent rounds of FMEA, I'll work my way down to any highly suspect individual process step. So I'm moving downstream. When I'm moving downstream, the cause of failure at one level will be the failure mode at the next lower level. So out in the field, the cause of the motor burn is the piston freezes. Next lower level, what's the failure mode? Piston freezes is the failure mode. What was the cause? The bent shaft was the cause. Next lower level, what's the failure mode? The bent shaft is the failure mode. What is the cause? Steel's too soft, and so on. Why am I going through this? Because I will bet dimes to donuts. Why am I spending so much time on this? Those of you with some FMEA experience, you've been in a FMEA project team meeting and you're listing your failure modes, and someone has said, is that a failure mode or is that a cause? Yes or yes? As soon as that happens, get your way back to this table and get back on track. That's the first indicator that you're starting to violate your scope. And you're going to end up wasting 3 or 4 meetings on a non-value adding detour. So that's the first thing the team has to do. What is our scope? And then before getting into the actual risk analysis, we have some options. We can generate a block diagram or a P diagram, parameter diagram, a structure tree, certainly in process FMEA, the process map. Maybe we'll make use of some other tools to get a good, solid initial visualization of the design or process structure and function. But then, and that's kind of out of scope for our webinar here, but those kind of some, before getting into the analysis, some options that the team has. But then as we get into the actual analysis, whether it be design or process FMEA, first in the function column, well, what are the functions, features, or requirements of this design, product, or process? What's the process supposed to do? Then we translate those into a failure mode. What can go wrong? No function, partial, over, degraded function, intermittent function, unintended function, etc. Then a curve that FMEA throws at rookies, people new to FMEA. See, as engineers, we live in a cause and effect world. Cause and effect, cause and effect, cause and effect. What does FMEA do? You list your failure modes, pick one, assume it occurred. What are the effects? It makes you go right to what are the effects if that failure mode occurs on the end user, for example, in design FMEA, on the customer, subsequent operation in process FMEA. And then we're going to be looking at some rating scales. By the way, Chris provided to you our electronic design and process FMEA spreadsheets. And there's a tab on each one of them that has the rating scales from the 3rd edition of the Automotive Industry Action Group manual on FMEA, published in 2001. We'll take a look at those briefly later on during the presentation. But basically the effects, how bad is it? Well, somebody could die. This could really affect safety. That's a 10. Well, you know, this could happen with no discernible effect. You know, the operator may just shrug and move on. That's a 1. So on a 1 to 10 scale. Then we go back to the failure mode. Assume it occurred. What could have caused the failure? Not what could have caused the effects we just listed. What could have caused the failure, and how often does it happen? What's the probability that cause will occur resulting in the failure? We then go back to both the cause and the failure modes and ask ourselves, how is it detected or prevented? What are our prevention controls, if any? What are our detection controls if the cause or failure occurs anyway? And how good are they? You know, here, the development engineer, basically, what are you doing when you're using that detection 1 to 10 rating scale we'll be looking at? Do I trust this test? You know, how often have you been sitting there? You get some test data out of the analytical lab and you say to yourself, I don't believe this. This is crap. You know, well, guess what? It's not going to get a good detection rating. Or no, I trust this test. I'm familiar with this test. I would release my design based on a good result on this test. Well, that's going to get a good detection rating. And then all of it rolls up into our risk priority number, which is a product of the severity rating times the occurrence rating times the detection rating. Again, severity on a scale of 1 to 10, an assessment of the seriousness of the failure mode effect. Occurrence, an assessment of the probability the failure mode and its cause will occur. The probability the cause will occur resulting in the failure. They're joined at the hip. Not the probability the failure will occur if that cause occurs. The probability the cause will occur resulting in the failure. And then finally, detection. That's an assessment of our current ability, design and process controls, to identify and detect the failure mode and or its cause before the design is released to production in design FMEA. Do I have good solid tests to detect a design weakness before release? or before product is delivered to customer, internal or external, in process FMEA. And there was a guy named David. Oh, and so we end up with our risk priority number. And here, many of our clients have kind of a 100-point cutoff. Risk priority number greater than 100, action is required. Less than 100, no action required at this time, unless the severity rating is greater than 7. In other words, a severity rating of 8 would be a loss of primary function. The product wouldn't even work. 9 and 10 severity ratings are reserved for safety and regulatory effects. So even if I have less than 100, if I have a severity rating greater than 7, that's never really put to bed yet, although I'm going to be working on a risk priority number of 576 before I'm going to be working on a risk priority number of 64 with a severity rating of 8. Others of our clients, in terms of, they will kind of tie their risk priority number, for example, in new product development, to their stage gate new product development process. In other words, they go with a red, yellow, green approach. If, hey, we got a risk priority number greater than 150, that's red. Stop. It requires action. You're not getting through this stage gate review. A risk priority number between 100 and 150, they'll call that yellow. You can move forward with management approval, but it requires some sort of rationalization about mitigation that exists if it's not going to be addressed at this time. And finally, risk priority numbers less than 100 blow through that stage gate, does not require action at this time. Beginning with their third edition, the Automotive Industry Action Group, they no longer have the 100-point cutoff. They just say, apply the Pareto principle. What are you doing about the highest one? I don't care if it's a 64. What are you doing about it? And I think in part that's because they recognize that, you know, and some of you might have even run into this yourselves during your own FMEA applications. Oh, wow, if that occurrence rating was 1 point lowered, we'd get under 100. You know, we kind of start gaining the rankings. Well, the Automotive Industry Action Group knew that was going on. So they just said, okay, fine, game it all you want. What are you doing about the highest one? But in new product development, I'm finding this red, yellow, green approach as being very, very helpful to people. I started to say there was a guy named David Simmerer who taught non-credit FMEA workshops at the Worcester Polytechnic Institute for decades. David loved the FMEA procedure. He loved the rigor. He loved the due diligence. He loved the debates and arguments that would break out during the analysis. He loved the structure of the ranking tables. And it would drive him crazy to sit in one of my workshops and I'd be kind of going through this and then say, none of this will improve your design and none of this will improve your process. Only the action you take will improve your design or process. The analysis itself is not going to improve it. You've got to take action, design change, process change, adding special controls, changes to standards, assembly procedures, etc., other guides. And now what I'd like to do is kind of switch over to what Chris had when you signed up. This is our Design FMEA worksheet, electronic spreadsheet. And where I really want to, we're going to go through this briefly, but really in terms of best practices among our clients is paying attention to the guiding questions in block 4 all the way across. They've said, man, this really helps us to stay on track. So in Design FMEA, we say, okay, what does the customer expect this product to do? Everything begins with the customer. For example, we're designing a new mousetrap, and the customer, they want it to catch a mouse, kill a mouse, attract the mouse, easy to set up, reusable, easy disposal, safe to set up, low price, etc. In Design FMEA, the failure mode is not the inverse of the function. For example, I want it to catch a mouse. The failure mode is not, does not catch mouse. The failure mode is not easy to set up. The failure mode in Design FMEA is not the inverse of the function. It's answering this question: what can go wrong? How could this product fail to meet one or more intended functions. So in the mousetrap example, no release, weak release, premature release. Those would be failure modes. Then we recommend pick one. Assume it occurred. And then you'll move on to list what are the effects of the failure mode. And we'll be looking at the severity ranking table shortly, where we will assign that severity rating. How bad is it? Then we want to consider, go back to the failure mode, not the list, the effects you listed. Assume it occurred. What could have caused the failure? And in design FMEA, from a design standpoint and from a design standpoint only. Stay in design, specs, material selected, etc. And describe in terms of something you can change or control. Nothing bogs down progress in an FMEA project team meeting more readily than the clever team member. Oh, we could get hit by an asteroid and then everybody's dead, and that's a severity rating of 10. Well, I'll severity rating of 10, you pal, get out of the meeting. We don't have time for clever. I have 6 children, I have 10 grandchildren. I've seen Star Wars. I know we could get hit by an asteroid. There's nothing I can do about it. Describe in terms of something you can change or control. And then for each possible cause of that one failure mode listed, we move on to consider our current prevention controls, if any. What current controls exist to prevent or mitigate the failure mode effect? And so consider, now you may, well, we've got SOPs, we've got written SOPs for the operators for setup. But then when we assign the occurrence rating, the probability that cause will occur resulting in the failure, that's when we're going to have a chance to judge our SOPs. You know, they're really not very good. They're really not up to date. So that's not going to help much in terms of preventing that cause of failure. Or they're really solid. They're really up to date. They're very user-friendly. And we have great evidence of people following them. Well, then that's going to have a better effect on reducing the probability of that cause and subsequent failure mode. And then we'll be assigning the occurrence ratings. Again, the probability the cause will occur resulting in the failure. And then let's say, okay, we failed to prevent the failure. What about our current design verification or design controls? What gave us our confidence in moving forward with or releasing this design, test, design of experiments, prototypes, life cycle testing, et cetera, virtual analysis? Excuse me. And then how good are these controls for detecting a design weakness prior to release to production? That's the detection rating scale we're going to be looking at shortly. And again, do I trust this? Do I trust this test? How good is it at detecting a design weakness prior to release production? Then we multiply our severity rating time occurrence ratings times detection rating, come up with our risk priority number. If it's greater than 100, or if it's in the red, recommended action. What actions are we going to take for preventing the failure mode, for mitigating its effects, for reducing the occurrence rating, the probability of occurrence, addressing or controlling causes, or improving detection? If all goes to heck in a handbasket and we still end up with a failure, do I have that good design control to capture that design weakness before release? For all agreed upon action items, who and when, who and by when? Because as you know, action plans without assigned responsibilities and checkpoints are dreams. Then once that action is taken and verified, we document the action taken, and then we update the severity, occurrence, and detection ratings. As a result of this change, have we reduced the risk? Have we ended up with a lower risk priority number? So that's our design FMEA worksheet. And also the severity, occurrence, and detection tables are embedded. Just hit that tab and you'll be able to bring it right up. For non-automotive people, wherever these things say vehicle, potential failure mode affects safe vehicle operation, for example, just substitute product. Potential failure mode affects safe product operation. Better yet, reword it and come up with your own rating scale. So these are a little bit small. I'm going to go back to the PowerPoint slide portion. Let's take a look at the detection ratings and how people use them, how they help them. So when we're rating severity, we're looking at the effects. If it's going to be an effect on safety or regulatory, that's 9 and 10. Loss of primary function. The product is inoperable. It does not affect safe product operation, but it doesn't work. That's an 8. Degradation of primary function. The product is operable, but at a reduced level of performance. And the second edition of the Automotive Industry Action Group's manual, they had an additional statement there on 7. Customer very dissatisfied. And I always urge our clients, even today, take out your pencil and add this on 7. Customer very dissatisfied. And then we get into loss or degradation of secondary functions, annoyance. This is appearance, cosmetic things. Has no effect whatsoever on the function and safety of the product, but people don't like to see those scratches, whatever it might be, on down to 1, no discernible effect. But you really have to beware of severity, any rating inflation. For example, I was working with a QSG client, and their marketing tail wagged the company dog. Customer is king, customer is king. Customer complaint, 10. That's a severity rating of 10. That's as bad as it gets. I said, no, customer gonna die, 10. Customer super ticked off, may even cancel the contract, 7. And no higher than a 7. You have to be careful about people inflating these ratings, because then what happens? You end up with an artificially inflated risk priority number, and you end up with design and process engineers having to spend time they don't have working on the wrong stuff. So it's very important, and we even build into our workshops actual several rounds of design and process FMEA applications on the client's designs and processes, because we're after calibration. We want to get to where that cross-functional team of design and process and quality and analytical lab people, yes, I'm comfortable with that. That's a 7, I agree. I know how we got there. So that's the severity rating. Then we consider the cause. And remember here, we're noting the probability the cause will occur resulting in the failure. Now here, the Automotive Industry Action Group makes an attempt to lend some objectivity, greater than 100 per thousand, greater than 1 in 10, 1 in 20, et cetera, to what is often a pretty highly subjective estimate, because I'm in design. I haven't released the design yet. How could I really know? Unless it's a design that's similar to previous design. So what I urge our clients to do, our FMEA project teams to do, just start with the words in the left-hand column. I think there's a high probability this cause could occur resulting in the failure. Okay, high 7, high 8, high 9. I think that's a moderate risk. That cause could occur resulting in the failure. Okay, moderate 4, moderate 5, moderate 6, and so on. But again, what I want to urge you, whether you're auditing FMEA documents or you're on the project team, anytime a team has an occurrence rating of 8 or higher, you must challenge it. It's not optional. You must challenge that rating. I'm not saying in all cases, but in many cases, what has happened? If this cause occurs, there's a high probability the failure will occur. That's not what you're ranking. You're ranking the probability the cause will occur resulting in the failure. They're joined at the hip. Here again is an area that's dangerous for artificially inflated occurrence ratings that result in artificially inflated risk priority numbers that result in design and process engineers having to spend time they don't have working on the wrong stuff. And when we get to the point of very low probability of occurrence, that's where the failure has been eliminated through prevention control. It can't happen because we have made a change by design. We have error-proof that design that it can't happen. And then finally, our detection ratings. Do we trust this? Do we trust this test? Well, it could start out, there is no detection opportunity, a detection rating of 10. We have no current design control. This particular failure mode or cause isn't even analyzed at this time. We're flying blind. That's a 10. Not likely to detect. Design analysis and detection controls have a weak detection capability. Maybe we're doing some finite element analysis, for example, but it is not highly correlated to expected end use. We're not flying blind, but our glasses are really dirty. That's a 9. Now, in their 3rd edition, what the Automotive Industry Action Group started to do, kind of cool, they started to reward you for getting good test data sooner, and conversely, punish you for getting the same good test data later. For example, as we get into detection ratings 876, we're doing pass-fail testing, we're doing test to failure, we're doing degradation testing. And let's say we really trust it. You know, we got a design weakness, these tests tell us. If it's done post-design freeze, prior to launch, that's going to be a 6, 7, or 8. In other words, congratulations for getting really good data. But it's post-design freeze. We might miss launch date. This might add some really unacceptable delays to the project. On the other hand, we're doing the really good pass-fail, test to failure, degradation testing prior to design freeze. Now, all of a sudden, the same tests are 3, 4, 5. So this table is crediting you for getting at good data early in the project when there's time to make necessary changes. Finally, detection rating of 2, we're doing virtual analysis that is highly correlated to expected end use. And finally, detection is no longer even applicable. The failure cause or failure mode cannot occur because it is fully prevented through design solution, proven design standard, best practice, common material. We're speccing it. We need a resistor, for example. We're speccing one in that we used in previous similar designs with no history of failure. Those are the kinds of things that we're getting involved in to get that all the way down to a 1. And talking about getting those ratings down, that is the goal in design FMEA. What do we want to do? We want to take action now during design to reduce the risk priority number via reduction in severity, occurrence, and/or detection ratings. Severity, however, can only be reduced through a change in design. Just because you make something less likely to happen doesn't affect the severity. I was in an online debate with people years ago, and the point that was many of them were making, no, if you really reduce the probability of occurrence, it's not as severe. And they're going on. I finally said, fine, shoot me in the head. You know, you can shoot me in the head this week, or you can shoot me in the head once in the next 50 years. The effect is the same. The severity of the effect is the same. So the only way you're going to get a severity rating down is through change in design to prevent that cause of failure or failure mode. Occurrence can be reduced by improving your engineering specifications and/or requirements. Detection ratings can be reduced by adding or improving design control techniques such as design of experiments, field trials, life cycle testing, etc. So that's design FMEA. Again, questions as they come up, just use the chat, get them to Chris, and we'll address those later. Moving on to process FMEA, other than stay in design. One of the major differences between design and process FMEA comes in the process controls column. Because remember, FMEA is never a one and done type of thing. It is a living, breathing document, constantly subject to future reference, referral, and update. It is an iterative process. So let's say early on in the study of a process, we're dependent on a type 3 control. A type 3 control seeks to detect the failure. You put a camera, you put a Visi system on the rail. As parts come out of the molding machine, it sees a deformation, a disfigurement of some sort. Pooh, it kicks it into the scrap sheet. That's scrap shoot. That's a type 3 control. If right now all we have is type 3 control, what we want to think about in future iterations of FMEA on this process, can we move to a type 2 control that seeks to detect the cause of failure? In other words, we know if the temperature gets too high, we can have that deformation at the top of the part. So we put an analog gauge on the machine with a needle, and if it moves into the red, the temperature is too high. So we're detecting the cause of failure. But again, ongoing subsequent iteration of FMEA, can we move to a type 1 control? Can we move to a type 1 control that seeks to detect the cause of failure from happening? Can we put a controller on the machine that doesn't allow the temperature to get too high? That's the type 1 control we want to be trying to move toward. Our process FMEA electronic worksheet, very similar to the design FMEA.
Hi, Jim. This is Chris here.
Yes.
I think it's a good time to address a question that came up on DFMEA on
Okay.
what we were just talking about before we get into the process FMEA.
All
And the
right.
question is for the criteria for DFMEA likelihood of detection, does later detection by the customer have a place in this classification?
If and only if customer trials are a part of your new product development process. If, however, customer has pointed it out, then that's because I've gone into production and shipped them something, then that's beyond design release date. There may also be cases, however, I'm not coming up with a brand new blank whiteboard, new technology design. I'm making a revision to existing design. There's a case where I could consider failure modes detected by customers in the past as potential failure modes that I have to address during my design FMEA. But man, if I'm waiting to get feedback from a customer, that's too late. Want to try to find a way to get it sooner.
Thanks, Jim. Andrew, if you have any follow-up or any other questions, you can use the chat, and I can also unmute you if you wish to ask Jim anything at the end of the presentation as well. All right, thanks, Jim.
Okay. All right, going back to where I've got something about low system resources may affect my audio quality. Are you hearing me okay, Chris?
Yeah, Jim, I hear you loud and clear.
Okay. At any rate, the same number of columns, the same severity, occurrence, detection, rating columns. But when here's another difference between design and process FMEA. We list the function. What is this process required to do? Always start with a process map. You got that thing up on the wall, and you have already agreed on scope. So what is this process required to do? Description of process being analyzed. For example, this is a coating process where we are to deposit a given coating without contamination onto a surface to a coating thickness of X plus or minus Y. Okay, considering failure modes, column C. What could go wrong? The next one is the key question. For what would you reject at this stage of the process? Well, contamination, out of spec coating thickness too high, out of spec coating thickness too low. See, in process FMEA, unlike design FMEA, your failure mode will often be the inverse of the function, because it's what you're going to reject for. Now, contamination, for example, you may not be doing a metal contamination test at this particular stage of the process, but downstream, we have a final metal contamination test that would detect metal contamination that could be introduced at this stage of the process. So even though I may not be testing for it here, it's still a failure mode within the scope of my project, because I would reject for metal contamination. And then we consider what are the effects of the failure mode. Now here again, no matter how good your process controls are, you must assume this failure reached end user, as well as effects on next operations, subsequent operations, etc. In terms of causes of the failure mode, what could have caused the failure? Not just by process, a bad design or formulation could cause failure in process. But also remember, describe in terms of something you can change or control. Then what current controls exist to prevent or mitigate the failure mode effect? Considering those prevention controls, we come up with an occurrence rating. Then current detection controls, what controls exist to detect the failure cause or failure mode? How good are they? That's the detection rating. We come up with the risk priority number, just like design FMEA. Any risk priority number greater than 100 or in the red, what are we going to do about it? What actions can we take now to prevent the failure mode, mitigate its effects, reduce the occurrence rating or improve detection, who's responsible, by when will it be done, once the action is taken, record the action taken, and update your severity, occurrence, detection ratings. Like we did last time, and you know, I probably should have given the warning of the administrivia. These are the ranking scales that a lot of people, it's just mind-numbing 1 to 10 ranking scales. I'm trying to make it as painless as possible, but the real key is, as soon as possible after this webinar, if you've got an active FMEA project, get in there and get people practicing using them. The severity ranking scale for process FMEA, the left side of this table is exactly the same word for word as the severity ranking scale for design FMEA, because it's considering end user or customer effect. And always consider your customer first, but we also consider any manufacturing or assembly effect, especially if it may endanger the operator without warning, or even endanger the operator with warning. So we apply both of them, whichever one is higher, whether it be the manufacturing assembly effect or the end user effect, that's the one that will be our severity rating. And remember, I forgot to mention, we only come up with one severity rating. You need not assign a severity rating to every effect, because you're only using the highest severity rating to come up with your risk priority number. I'm amazed the number of clients I work with, you know, they spend 1 or 2 meetings arguing over their severity ratings for all their effects. You're only going to use the highest one. You know, so then once you assign a severity rating, from then on, as you're looking at the effects, and let's say the severity rating was 8, loss of primary function. Is this going to be greater than 8? If no, move on. Is this going to be greater than 8? If no, move on. Is this going to be greater than 8? If no, move on. So save yourself some time. And then as we continue to consider the manufacturing or assembly effects, we get into scrap, rework, downtime, etc. A minor disruption, severity rating of 2 for the manufacturing or assembly effect. It's a slight inconvenience to the process operation or operator, but the operator can handle it. And finally, there could also be no discernible effect. The probability of occurrence, again, the probability the cause will occur resulting in the failure. We will have an occurrence rating with every cause listed, cause failure mechanism. And again, I recommend to our clients, just start with the words. Don't get hung up on the, well, it's 11 per thousand or 9 per thousand. Start with the words. I think there's a high probability this cause could occur resulting in the failure. Okay, high 7, high 8, high 9. Moderate risk, low probability. Okay, low, 3, 2. You know, kind of start that way. And again, just like design FMEA, however, audit or participation in an FMEA document. Anytime you see an occurrence rating greater than 8, you must challenge it. You must challenge it. Get in the habit of challenging it. Because again, not always, but too often, what they've done is they said, if this cause occurs, the probability, there's a high probability the failure will occur. It's not what we're ranking. And then finally, detection. This is interesting. Well, there's no detection opportunity. Detection rating of 10. We can't detect it. It's not tested. It's not analyzed. Not likely to detect. Failure mode or error or cause is not easily detected. We're just doing random audits. Problem detection post-processing. This is just visual, tactile, human inspection. That's an 8. Sometimes you can get it down to a 7 visual inspection if you have double super secret visual inspection. But for the most part, beginning at 7, we're starting to get into use of attribute gauging. 6, we're getting into some variable gauging or in station by operator with attribute gauging. We're starting to put some measurement instruments in the hands of the human. Failure mode detection at source, failure mode or error cause detection in station by operator through use of variable gauging. That's a 5. Failure mode detection post-processing, look at that 4. By automated controls. Now we're starting to get into automation that will detect discrepant part and lock part from further processing. This thing can't reach next operation. And then so on, all the way down to the point, again, 1, it's the same as the occurrence rating table, by the way. The error or cause, we're in error or cause prevention. As a result of fixture design, machine design, or part design, discrepant parts cannot be made. So in process FMEA, like design FMEA, what is our goal? Take action now. to reduce the risk via reduction in severity, occurrence, or detection ratings. Again, severity can only be reduced. The rating can only be reduced by a design change to product or process. Occurrence can be reduced by a change which removes or controls a cause, redundancy, substituting a more reliable component by design, for example, error or mistake proofing. And finally, detection can be improved by deploying better controls, mistake proofing, simplification, statistically sound monitoring, better gauges, moving into some automated controls, etc. And in general, we always teach reducing the occurrence rating, making it less likely to occur, is preferable to putting a lot of resources into improving detection. We would like to find ways to detect failures from to prevent failures from occurring or reduce the likelihood of occurrence, then get better at catching it when it does happen. So, and then I just want to very briefly touch on something here before opening to questions. We complete our design FMEA project. We're very comfortable with the product characteristics and key measures that we've generated, specifications, good, et cetera. We've completed our process FMEA. We've got a good process, good at this time and capable of producing good product to the good design. Now we have to hold the gains. Your design and process FMEA project teams have disbanded. How do you know that all of their work will remain as opposed to our operators getting sucked back into their old habits of eye and feel? This is the role of the control plan. The process FMEA feeds so design FMEA, process FMEA, that feeds the control plan, where we want to get all of this critical product and process information into the hands of the person working closest to the operation. We're providing him or her, for example, characteristics and key measure information related to product and process coming out of the design FMEA and process FMEA. We're going to be giving them the specifications or tolerances that we came up with in design FMEA. We've told them what's important in terms of design and process characteristics. What's the evaluation or measurement technique? Visual check, variable gauge, etc. We said these are important. Fine. How many and how often? How many do you want me to check and how often do you want me to check it? What's the control method? What do I do with the data? X bar R chart, attribute chart, batch record. And the last column, reaction plan, when all goes to heck in a handbasket, despite our best efforts, and we just go out of statistical control or out of specification, what do I do? We have to let the operator know that. Segregation of non-conforming product, whatever correction method has been specified, sorting, rework, repair, customer notification, in all cases without exception, immediate notification of team lead or supervisor. So I just want to very briefly touch on control plan. I know this is an FMEA webinar, but that is what you're using to hold your gains and to combat the entropy that's going to be out there trying to pull people back into their old habits of eye and feel. So that's thank you for taking the time to sit on the webinar. Other questions might have come up, questions, comments, curses. So I'll just turn it back to Chris to raise any of those.
Thanks, Jim. Great presentation. We do have some questions that came through in the chat. And the first here is, in aerospace, as a supplier to OEMs, does the creation of design FMEA lie with the OEM who has DWG design authority, or the supplier who will MFG the component? Should the OEM provide design FMEAs to suppliers who could drill down further into process FMEAs? Did you get all that?
Yeah, in the best of all worlds, yes, but they're not going to. They're not going to give away their proprietary store as far as their design. There again, what is our scope? The aerospace, the F-16 or manufacturer is going to be dealing with the system. What is our scope? What are we giving into that? And then whatever information is provided to us will help us to consider effects on that higher level, be it subsystem or system. But I guess I would push this back on the questioner and say, have you ever had a case where the aerospace manufacturer has handed you his or her design? Because that'd be a first to me.
Great. All right. Thanks, Jim. And then we have a couple praises. Great job. Always love attending your presentations. Thanks very much, Jim. Very helpful presentation. We are working on FMEA at this time, and this is going to help me. A few more of those. And then we have a comment from a little bit ago. I don't think I read out. It might have been in response to the first question we asked, and it was, you can take the current customer identification of a failure and apply it to your next generation design.
Correct. Because remember, our next generation design, again, assuming it's not blank, but well, I suppose it could be a blank whiteboard, new technology. We're always learning from our customers, but we consider that as an input in the function column. What does the customer expect us to do? We do not rely upon that as a detection control, as a design control. But no, I would agree wholeheartedly with that point. I don't know who's involved in that project right now. I do want to jump on something because Angelo Skankis and I always have a lot of fun with this. I really, if there are no other questions, I want to just go back to and really stress this difference between design and process FMEA. If that questioner's current project is design, stay in design. So remember, all potential causes should be design-related causes. Bad material, that's process. Material tensile strength spec, too low, that's design. So again, that four-letter word spec. Design FMEA does not reference manufacturing controls. This is another one I ran into with that client. Some of the design controls were incoming inspection and in-process inspection. Well, I haven't released the design yet. How can I do incoming inspection? You know, those kinds of so-called design controls, that ain't nothing. But coming up with an excuse to transfer a bad design and expect the process people to burn your toast and scrape it for design life. But no, we do not reference manufacturing controls. Our design controls, stack up analysis, simulation, FEA, I mentioned these, DOE, et cetera, feasibility reviews, and all recommended actions. We want design actions, redesign, introduce, test out alternative components, for example, testing analysis. So I did kind of want to just touch on that very briefly. If that person was in a design FMEA project, maybe he or she can use this slide when they get copies of the slides from you, Chris.
Yeah, absolutely. And there's been a couple of questions around that as well. By the end of the week, you'll receive the PDF slides for today's presentation, as well as a link to the recording. If you have any questions for Jim, you know, even after the webinar, after you receive material, you know, you can always reach out to myself or Jim. All right, Jim, we have another question in the Q&A, and it's, can you give an example on how a process change can improve severity?
A process change? No,
Yeah,
usually severity is only improved through a design change. We have to find a way to prevent that cause of failure from happening. So take, for example, a setup error. A setup error on the machine causes not only damage to product, but potential severe safety effects on the operator. So we get to a point that we come up with an automated, controlled setup procedure that is no longer dependent on the operator touching and remembering where to put things. And we put that automated control system through life cycle testing, that we are not going to end up with that particular setup error that would endanger the operator. And we have that proven. I suppose you could call that a process change, because we're making a change to setup procedure in process, but it's nonetheless a major change in design in terms of process design, setup procedure, automated versus manual, super tested out with life cycle testing. Yeah, then I'm not going to have a 10 severity rating of potential injury to the operator, because he or she's nowhere near that machine during setup anyway. and it might just move down to the point where there may still be some sort of a little bit of damage to part, a little bit of downtime, but my severity rating would go from 10 to maybe, 5, 6. But notice that's a pretty major design change, and that's a heck of a lot of life cycle testing to make sure and to prove out that I have prevented that severe incident or injury by design.
Great. Thanks, Jim. All right. Another question in the chat. How can design folks and process folks work together to have a coherent design and process? Inspection and quality can be in concurrence for product delivery.
Yeah, I mean, this is something just to fit into our time frame. I had slides on team structure, responsibilities for team leaders, responsibility for team members. We at Quality Support Group have always recommended cross-functional teams. We never, in a design FMEA project, include design engineers only. We want process representation. We want somebody there from purchasing. Marketing is supposed to be the source of voice of the customer. I'm not saying they have to serve on the project all the way through design release. There will be some tables that are some chairs at the table that are rotational, but I need marketing there at the outset. What does the customer expect this product to do? So by the team sponsor or champion assigning design and process people to the project team, they will be working together because they're going to be doing the project together. It's also, I find, very helpful to the design engineer, because if they're thinking about something in design, having a process person at the table able to say, we can't do that. We can't do that right now. Oh, gee, I wasn't aware of that process limitation to be able to produce that design characteristic. So, oh yeah, I mean, having process people there is critical. And I would even want to have some design representation on the early stages of my process FMEA project, because that's where we're making that, we want that seamless transition. I don't want to have the design people having to lob a design over the wall at me without my involvement prior or their involvement post-design release.
Great. Thanks, Jim. I just want to let everyone know too, is we can stay over 1 o'clock a little bit if there are more questions, but feel free to drop off if you can just stay with us for the lunch hour, or if you have other meetings at 1. Also, if you have questions and you have to jump off, you can also email me and I can put you in touch with Jim. But we can stay on and answer some questions a little past 1, if that's okay with you, Jim.
Yes, that's fine with me.
All
Thanks,
right.
everyone.
Great. Then a question in the chat. What are some of the best ways to attack the process FMEA when you are looking to manufacture parts that you are building per a blueprint?
It would, again, go from the standpoint of thinking that failure modes column, what could go wrong? And then into potential causes is, and this would be a human error type of thing, did not follow print, did not understand print. I mean, I think some people would have a tendency of looking at the blueprint, this not the same way, but very close to the way that other people look at the standard operating procedure for assembly, for example, the SOP. Is it complete? Is it clear? Is it understandable? To what extent have we engaged the operators in this process FMEA so they have every opportunity to point out concerns with that blueprint? I guess that's what I suggest that you share with people, that, okay, let's view the blueprint as a form of a process SOP, a standard operating procedure. Is it complete? Is it clear? Is it understandable?
Great.
The other thing, I would hope as that blueprint comes out of design that we've really double checked and make sure we're not mixing up millimeters with inches, for example. I mean, and that's, I'm not being facetious, that's actually happened, a mix of metric and inches on prints. People just didn't catch it before release to production, and that caused all kinds of problems. So that's also something that wouldn't it be cool to have at least one process person on that design FMEA project that's producing that print and the specifications that are included on that print? That'd be cool.
Great. Thanks, Jim. I don't see any other questions that are popping up. Maybe we can give everyone another minute or so if they're typing any questions. But if not, then I think it's a good time to wrap up. Thanks everyone, for joining. Thank you, Jim, as always, for a great presentation. And yeah, if you have, like I said, if anyone has any questions or you'd like to continue any conversations with Jim, please let me know. And then I hope to see you guys in other webinars coming up and other QSG workshops. And if you enjoy our free webinars, please leave us a review on Google. You can just Google Quality Support Group. I think we have over 130 5-star reviews, and we really appreciate any reviews. And you can mention Jim's presentation specifically, so Jim can get some praise as well. So thank you, Jim. I know Navy had a tough game the other day, huh?
Oh man, this is a tough season. It's like when I was there. Oh, it's awful.
Yeah. All right. No other questions came through, Jim. So have a good day, and thank you, everyone.
All right. Thank you. Take care.